Welcome back, everybody, to part 3 of PRO-CEDURAL. Is it 50% harder than part 2 or 3 times harder than part 1? I don't know. Either way, we're back. One tiny note before we continue on to the nodes, and I guess I should just mention this. Clearly, I'm in a new place. I mean, it's no longer dark or anything, but I moved, meaning that there's going to be some echo for now, because I don't have a rug, I don't have curtains, there's nothing to absorb sound, so this mic might get some reverb, but maybe that makes my voice sound better. I don't know. This doesn't really matter. Okay, so we're back in PRO-CEDURAL, the scene that we left off with. What did we do? Well, we made all our geometry, again, using displacement maps. So we created our cone mask, we created our rounded square, and then the rounded square with margin, just to solve that issue of clipping. Which, again, we can make the margin smaller if we were to render, because then we actually get more subdivisions. Because here we're only previewing 1.6 pixels, here 0.2. We already talked about all this. So let's apply our displacement. This is where we left off. We have all our geometry, and now the question is, it has the shape of the cone, but how do we make it look like a cone? And the answer is, it's pretty much the color of the surface, how reflective it is. Controlling stuff like this is what makes it look like a cone. So for example, if we were to take our diffuse BSDF, which is what you're seeing, notice that, again, this is a plane, meaning that there should be geometry here. And there is, but we just made it transparent. So again, this is what it's supposed to look like, but we just did a bit of a trick to get rid of it. But yes, we're viewing the diffuse BSDF, so if we were to change the color, we can make it look more cone-like. But before we get into stuff like that, you might notice, or you might know, that most cones have stripes. And that's the thing I want to talk about now. So we could make the whole thing orange, but at least cones in the US, they have a stripe here. Usually they even have 2 stripes. So we need to make a mask for where we want stripes and where we want not stripes. So where do we want white and where do we want orange, basically? So I guess we're doing one more tutorial about mask creation, which is pretty much the whole idea behind procedural nodes, is just making masks. But let's make our stripes. So first approach you might think about is, okay, I want to make a stripe here and here along the cone. Well, we can actually define those regions by how tall they are. So if we were to take a geometry node, look at the position, this just outputs a vector for each point. At each point, it looks at what its position is, and then it colors it accordingly. If we were to separate by x, y, z, and look at the z component, or the z-axis, which goes, up. As it goes up on the z-axis, it gets brighter. You might think that this is an approach to do it because that defines different heights on the cone. In fact, if we were to do something like I guess we could just go directly to a color ramp node. We set this to constant. You can see we're already defining what this is going to look like, right? We can just slide across the cone. This is one approach, but there is a major issue with this, and that is, remember, we made all these parameters that we want to be able to control our cone with. One of them is cone height. And if we were to change how tall this thing is, the stripe doesn't really move with it. It is procedural what we did, but it's not really a smart approach. It's kind of like dependent on a certain size, where we want everything to be independent of each other and just work in unison. So maybe dependent is the word I'm looking for. So we're not going to be using this approach. Instead, we're going to be doing a similar thing to what we did, the other time with the cone, which was, let me disable displacement. It was creating a radial gradient, which uses this length operation using our texture coordinates. We already talked about this. And the nice thing about this is it kind of, in some sense, deforms with our geometry a bit more. And even if not, it's just a nicer way to work. So we're going to be doing something like this. So you might think, oh, we can use this length thing. And in fact, we can't. Why? Well, it's because of the same issue as before, where we now have this height component that's kind of controlled by these parameters. So we need to make it independent of that. So how do we want to do this? Well, a nice way to do this is we're going to separate XYZ and combine XYZ. So we have a node to break our vector and a node to create our vector. So let's take our texture coordinates, put it in here. Let's have a length in here. And then I'm going to connect, let's say, X to X, Y to Y, and Z to Z. Okay, so what have we done here? Well, basically, there is no difference between this chain, right? Just going along here and going along here, because separating and combining and doing nothing in between means nothing happens. So here's what it looks like before, after. It's essentially the same thing. But if we want to make it independent of displacement, in other words, independent of the z-axis, all we have to do is sever this connection. So now it's still calculating the length, but it's calculating two-dimensional length as if we never actually displaced this upwards. So this is the useful thing. So you can see that when we make our plane have no displacement, these are equivalent, but the moment that we add in displacement, in other words, we add in some variation on z, you can see that now there's actually a pretty big difference. And since this is independent of displacement, we can now make our stripes in a way that kind of works better with the procedural approach. So I'm thinking we do the same approach as before. We're just going to use a color ramp. We're going to set it to constant, so we have these nice sharp fall-offs. And then all we really need to do is kind of define the area of our stripes. Okay, so I'm thinking we start off with like a stripe here, which means that we should bring down the Y. I always get these mixed up. I guess you could do it either way. You could bring this. I guess you can't do it either way. You do need to bring this down. So I'm going to keep bringing it down until we're at the top area of our stripe. So I'm just going to pick something like that maybe. But of course we don't want, imagine the white area is our stripe. We don't want this entire thing to be the stripe. So we just click add, which will add another black handle. And then we just bring it to the other side, which will give us the thickness or the width or the size of our stripe. So we're just going to be able to control that. And then let's click plus again, which will give us a white handle. We bring it to the other side. And this is how we make our second stripe. You can just continue, and you can make as many stripes as you want using this method. But you can see how this idea of using a color ramp is actually fairly similar to the idea of using a RGB curves, where it is procedural. We do have complete control, but it's not in the sense of like value nodes. Like we need to manipulate this node itself and pull the handles. There's a way to do it like nice and mathematically with the value nodes and the math nodes. We're not going to do that. This is like the fastest approach to do it. So I'm just going to be pulling around these until I'm happy with the positioning of our stripes. Something like this maybe. And again, like we talked about, and this is the key idea of part 3 of PRO-CEDURAL, it's independent of displacement. So let's make this a mask. Let's just for now use it as our diffuse PSDF color, meaning it's going to inherit this as the color, so it's going to be black wherever there isn't stripes, white where there is stripes. If we were to now disable displacement, you can see this is what it looks like because it's independent of Z. It's just kind of like projected down to the XY plane. With displacement, and the key idea is as we bring down our scale, meaning the strength of our displacement, you can see that these stripes kind of move with the cone, right? That's the key idea here. And if we were to manipulate our cone height, you can see that these stripes stretch with it. Of course, they become longer because that's the only way to do it, where they maintain the same ratio of height up the cone. Hopefully all this makes sense. Again, key idea, these stripes move with the cone, whereas the approach with the just this length without the getting rid of the Z component doesn't do that. Okay, so now we've isolated our stripes, and I'm thinking for now, just to make it look a bit nicer, we can take this color ramp, which basically outputs either black or white exactly, because we set it to constant. There is no fall off like there is with ease, right? It's just like that. What we can do is we can use this with a mix Rgb node. So it's going to process through this before it gets to color. We're going to use this as the factor. And we can say that the color 1 should be white, I believe. No. Color 1 should be orange. So this is the color of our cone. And color 2 should be, white. And basically, you can pick whatever you want for this. So I'm just going to use some colors for now. We can change these later just so we can see what we're working with. And now what I want to do is make these stripes a bit more interesting. Yes, they follow our, geometry. Yes, they're in the correct position. But in some sense, they're like too perfect. And if you look at real cones, there's a bit of distortion. It's not like a perfect line. So I'm going to tell you how to do that because it's a nice trick. So if you're thinking about how do I kind of distort these stripes, well, we can either mess around with color ramps and do some complicated math. That seems like a lot of work. What if instead we do it before we reach this step? We actually manipulate the texture coordinates To begin with, we manipulate these, and then as it goes through, it just propagates that change to make the distorted stripes. That would make a lot more sense. And in general, messing with texture coordinates is a much smarter approach than messing with, whatever happens afterwards. So we're going to stick with the purple socket area. So here's the trick. What we're going to do is we're going to add in a noise texture. Again, this is procedural. And what we're going to do is we are going to not enable caps lock. We're going to do a vector math node and add these together. You can use factor or color. There's a bit of a difference, but I don't think we're going to go into it in this tutorial. What this is going to do, you can see what this is doing is it's, distorting our texture coordinates, meaning it's making our stripes like heavily, in the wrong place, but they are wavy. And the idea is we took our texture coordinates and we added just a bit of randomness or noise texture, whatever you want to call this. And we can actually control this to get different weird stuff happening to our stripes. Okay, so it's kind of the right idea, but our stripes have now moved far away from where they're supposed to be. Why? Here's the key idea of this part. Noise texture, what it does if we view it, is it gives every point on our cone a value between 0 and 1. There's an algorithm to choose what that is, but that's what a noise texture does. Every point gets some value between 0 and 1 that's effectively kind of random to us. That means on average, if you do this over infinitely many points, on average, we're adding 0.5 because if it's between 0 and 1, some values are going to be small, some of them are going to be big, and overall, if it's a uniform distribution, on average, you're adding 0.5, so halfway in between. On X, Y, and Z. So in every axis, you're on average adding 0.5. That means that when we look at this addition, and let's actually view the whole thing, that means that on average, the whole thing is shifted by the vector 0.5, 0.5, 0.5. And you already know about translation and all this because we've been using, not in this group node, but in this one, we've been using the add vector math all the time just to shift our coordinates, right? So this is what's happening. It's shifting our coordinate system by 0.5, 0.5, 0.5 on average. So to correct for this, what do? Well, if you want to get rid of that 0.5, 0.5, 0.5, you add or subtract, but we're going to go with add negative 0.5 on XYZ. Boom. Now you can see our stripes are somewhat in the right place, and in fact they are. But even if we distort this, they kind of stay centered on that area. So we're closer to what we want. We're not really there, but we're closer. And this little node group right here, this kind of texture coordinates, add noise, you add noise, and then you add this correction term, which shifts everything back. This is a famous trick in Blender for blurring. It's fake, but fake blurring textures. So if we were to make this scale something like 1,000, effectively what this does is it takes our two stripes and just blurs them. That's the idea. And it only works when you pick a very large number for the scale. This is close to what we want, but really what we need is to have more fine control and just distort the border, not this entire thing to blur. We don't want this. So, in other words, we kind of want to control the strength of this effect. So if you're following so far, good, because this is a complicated idea. If we want to control the strength of this effect, let me try duplicating that again. What I'm going to do is before this reaches the addition, so before we include this to our texture coordinates, let's affect the strength of it. So I'm going to put it through a vector math node set to scale. In other words, this number, this scale value is going to be the strength of our noise. And let's plug that in here. So this time it's being processed through a scale. And right now it's set to 1, which means that nothing has changed. We're multiplying by 1. Nothing's different. But if we were to change this value, you can see that different stuff happens. And we're getting the same issue with shifting. Right now it's going up the cone. And the reason is, again, we do have our correction term, but that is dependent on what we do to our noise. Before it was going from 0 to 1, so on average we have to shift back by negative 0.5 on XYZ. If we were to make this a different value, then our correction term also changes. So that means we need another scale node. We're going to plug that in here. We're going to use minus 0.5, that's our correction vector, and then scale it by the same amount. So let's add a value node, plug it in here. So this is the strength of our noise, and this is the strength of our correction term. If our noise is half as strong, 0.5, our correction term only needs to be half as strong, doesn't need to overshoot. And now you can see that we can drag this slider, everything stays centered, and if we get pretty close to 0, you can see that we keep our distortion, but everything stays centered because our correction term is correct. And we actually have even more control over this because we can still affect the size of our noise. So if we were to make this like 50, everything stays in the right place. It's just, more distorted. We could add detail to add like a bunch of sharp edges and all this. And that's the main idea. So what I'm going to do is, since we have another value node, I'm going to add it to our collection of parameters. This one we can call, what is it? It's essentially a stripe distortion. Maybe we can just call it stripe, since we're not using any other parameters for our stripes, I don't think. Again, you can mess with this color ramp so that, maybe we should add one more parameter. Like, for example, what we can do is we could do a math add, and you can think of this as just shifting. So if we were to make this a bit bigger than 0, we're shifting it up and down the cone, and it actually will stick regardless of displacement for the same reason as before. So let's actually add that in. So this one I'm going to set to 0 by default. We can call this one stripe. And by default, it's using 001 because we already named something stripe. And for this one we can call stripe distortion. So we have like pretty much a parameter for everything we could ever want right here. So stripe, how translated do you want it? Stripe distortion, how distorted do you want it? And again, there is a purpose for this. It's kind of like, when you look at cones, they are a tiny bit distorted. I swear the lines aren't straight. But even if they are, this is a valuable lesson to learn. So I'm going to keep this very subtle. Something like 0.02, see what that looks like? That looks interesting. It's much better than a straight line, maybe 0.01. Just so there's a tiny, tiny bit of variation. Okay, so now essentially what we've done is we've created our mask that we can distort, we can shift, and just to keep it interesting, again, this is what it looks like without displacement, because again, we're just kind of projecting to the XY plane. Since we made it independent, there is no Z, we made it independent of Z, but we can actually visualize what all the nodes we've added do. So stripe is going to shift it up and down, which means it's going to make it bigger and smaller. So let's see that. Whoops, made it too big. Let's try that again. So you can see now these are just kind of shrinking, but the ratio of like width stays the same. So that's the idea there. And then stripe distortion will just kind of distort it on this plane and then bring it up with displacement is the idea. Okay, so now let's visualize this whole thing. And I like how it actually keeps that transparent boundary that we made. Let's look at this again. There we go. And something that might be interesting just before we wrap up part 3 is I'm going to add one more parameter for the strength of our displacement. So I'm just going to call this one displacement. And this is something we generally want to keep between 0 and 1 because we've already done all our scaling and everything before we reach the height of the displacement node. So no need to do it within there. So what this does is it lets us actually flatten our displacement and visualize what happens as we create our cone. And I do like the idea of also having this affect the color. So let's also do another mix RGB before it reaches our diffuse BSDF. This will be the first color. White will be our second color, and our factor, whoops, will be our displacement, if I can even see that. Such a small thing. And I guess we should have these flipped, it looks like. I think. Let's see. I think I flipped the wrong ones. This should be here. Okay. So what does this mean? This means that when it's 1, we have pretty much what we made. But as we go to 0, it will flatten and turn white. I guess it's not really doing that because we have the wrong color. So let's make that saturation 0. Okay, so again, this is just a cool way to visualize. It's in the tutorial intro as well. In the beginning, you saw this animation. Okay, and then we also want this to affect the transparency. So we want there to be no transparency when it's at no displacement. And I didn't really think ahead, so let's just try things and see what works. So let's try something like that, maybe a subtract and clamp. Nope. That is absolutely not doing it. You know what? I can think about this later. It's not that important. It's obvious, but when you're on the spot making a tutorial, let me tell you, it gets complicated. So now we have a nice, maybe displacement isn't a good way to describe it. Maybe transition is a better way because we're also affecting color. So now we can also, do that thing. So there you go. That's the that's how you add stripes. I guess it's a good idea to somewhat clean up this mess. You know what I say? Whenever there's too much going on, just throw it in a node group. So that's what we're going to do. We just want to make sure all our parameters are exposed so we can control them outside of the group again. It is a shame that the color ramp node has to go inside the group, but oh well. So let's just get all of that. Control G to put it in a group right there. And let's clean it up just a bit. Cool. So now we have all our parameters going into the stripe mask. Let me get rid of that. Actually, I guess this isn't it is the stripe mask. We have that. We have the, this thing, the cone mask, rounded square, margin square. You can clean it up on your own time. This is just a demo. But yeah, okay, so we've made this much more procedural. We've added in the last mask we need, and then the rest of this tutorial, which is not this one, but the next one, part 4, we're going to be talking about how to make this just look a bit better. So yes, we could like reshape our cone using some of these parameters. Like for example, I feel like our cone isn't quite tall enough, so we can make our base height like 0.15 just to make it a bit taller. We could do stuff like that, but I want to talk about how to make it reflective in the right areas, how to add dirt, using ambient occlusion, stuff like this. But yeah, there you go, part 3 of PRO-CEDURAL. Thank you for watching. Okay, so we're at the end of the tutorial, which means it's time for the Patreon pitch. Don't leave yet. I do have something to say. If you like these tutorials and want to support me making tutorials, and more importantly, maybe get certain benefits like exclusive tutorials, Discord access, behind the scenes access, tutorial files, stuff like this, do check out the Patreon. This is the best way to keep this channel going. It's actually the most reliable revenue stream in all this. Patreon is where you want to go if you like everything I do and you want to get some behind the scenes and all this. And I feel like I forgot the rest of my pitch. That's generally the idea. But either way, I hope you enjoyed this free tutorial, and let's move on to part 4 when I release it.